Introduction to Swing. I've given you enough background in Java, syntax-wise, and you have a good understanding of classes and whatnot, so we could start doing graphical user interface computing or programming. Graphical user interface meaning, creating Windows applications with menus and pull downs and labels and buttons and all sorts of cool stuff. Now, in order to do GUI programming in Java, you have to understand where the classes reside that contain the GUI functionality. And those classes reside in two main categories of classes. You have the AWT classes. AWT is essentially the original abstract windowing toolkit classes that came with Java pretty much from the beginning. Java has done a various amount of graphical user interface programming. And Java 1.0 and 1.1 had what was called the Abstract Windowing Toolkit, which became known as AWT. Then later on, Java 2 platforms added what is called JFC, or Java Foundational Classes. And JFC has what became known as just Swing. And it's a lot more elegant, a lot more prettier components that Sun Microsystems provided for us in the Swing set of components. And that's what we're really going to be focusing in on, are those Swing components. Now, Swing does not replace AWT. It's very important that you realize Swing doesn't replace AWT. It enhances or builds off of it. Swing gives me an accessibility API for programming applications that need accessibility functionality. It has enhanced 2D graphics capabilities. It supports drag and drop, and it supports something called the pluggable look and feel, which basically allows me to change the look and feel of my application on the fly, which is pretty neat. Now, the basis of a Java application is a frame. And what we put on that frame are things like components, like buttons and labels and things like that. So a nice methodology has emerged as a pretty good set of rules for working with GUI. And it's about 5 steps in that methodology that we're going to go ahead and take a look at. There are essentially 5 techniques, 5 steps involved to GUI programming in Java. The first thing that you're going to do is create a top-level container. And that's usually going to be what's called a JFrame in Swing programming. Then you create components like buttons and labels and text boxes and whatnot, and you put them on the container. And you have a way of laying them out, positioning them where you want to put them. Then what you do is event handling. Event handling means they will respond to when like a user clicks a button or types some text in a text box. Now, event handling requires us to understand inner classes and anonymous inner classes. So we have to have a conversation about inner classes before we get into event handling. So we'll come back to event handling later on. Then we kind of size the window, say how large or how small we want it, and then we go ahead and show it. So now that we have a good fundamental understanding of what's going on with Swing, let's start digging in. All right, I'm going to bring up TextPad here, and we're going to start writing our first very simple, very basic frame. And in order to do that, I have to import a couple of packages. Now, the import statement always precedes class declaration, and it allows me to have access to the classes inside of a particular package. And we're going to be talking a lot more about packages later on. So for right now, I just want you to kind of take on faith that we have to import these packages. And I'm importing several of them because we're going to use them. Now, the key packages to import for Java Swing development are java.awt and javax.swing. Okay, so let me go ahead and comment that here. This is used for GUI development. These two, you might remember we used when we talked about setting the dates, util and text. I'm going to revisit with that here in a little bit. And this is used for GUI development. And I think you can see by the name of the package itself that it is used for Swing development. Okay, So let's create a class, public class swing1. Right, and I'm going to save that off here. Put that in my C Java directory, and I've got, let's see, got my swing folder, and I'll call this swing1.java. Now what I'm going to do is create a constructor. Remember, constructors are those special methods used for object instantiation that has the same name as the class that it is used to instantiate. And it is at this point that I want to go about showing you the various ways of programming styles in Java, utilizing what we've learned. So let's just start out with the most fundamental way, or the most basic way, of displaying a form. Okay, so I'm going to say JFrame. JFrame is going to be my top level container. You'll see what it looks like here shortly. My JFrame equals a new JFrame. And there is a method called setText, myjf.setText, which is basically going to put a caption along the top of the JFrame, and I'll call it CBT Nuggets app. Okay, I'm going to say myjframe.setSize, and let's make it 300 by 300 for now. And then I say myjframe.show. Okay. Then what we're going to do is come down here and give ourselves a main method, public static void main string args. And because I don't need a specific reference to the object, I'm going to just do an anonymous reference, and I'm going to say simply new swing 1. And go ahead and compile that. And I get a compiling error. And the reason why I get a compiling error is because I called the wrong method. I called the setText method. So let's go back and change that to the setTitle method, because what it's going to do is set the title of the JFrame. So let's go ahead and recompile. And now I'm going to run it. So I do a Control-2. And you see the DOS window come up, and you see the frame emerge. Now this is the basic frame. This is what you get, okay? The frame automatically gives you a couple of a little bit of functionality here. I can minimize the frame, I could maximize the frame, and I can exit the frame. Now, I didn't mean exit as EXIT, I meant exit as X-ED, because you see the DOS window here running? The application is still running. It's just the window's not visible. The default behavior of a JFrame does not give you the ability to go ahead and actually exit EXIT, the Java virtual machine session that's running it. That will have to come later with event handling. So let me kind of review what I did here. Here I created, here I have my 4 import statements, okay? And this gives me access to the classes in the various packages. Then I created a class. Then I created a constructor. And in that constructor, I went ahead and I instantiated a new JFrame. I set its title, set its size, and showed it. And then what I did was I went ahead and within the main method of the class, I instantiated an instance of the swing1 class. But what I prefer to do now is get rid of this, because I think the preferable method isn't to instantiate an instance of the JFrame with inside of the JFrame or the class that's supposedly representing the JFrame. What I like to do is I like to go ahead and create my own JFrame. So to create my own JFrame, I have to take advantage of an is-a relationship. Hopefully that is-a relationship sounds somewhat familiar. So I'm going to say import java.awt.star. Import javax.swing. dot star. Okay, and I'm going to say public class JF main extends JFrame. Now recall, the extends keyword means inheritance. So what I did was I created my own class, JF main, that is a JFrame. Let me write this out for you in English just as a quick note. Here, inheritance defines a relationship that we call is a or an relationship. Okay, so what I have here is I said JF main, a class that I made up myself, and because I'm using the extends, it is a JFrame, and a JFrame is the real class in the Java API. And because I've inherited from it rather, I now have access to all of the JFrame classes and all of what it inherits in terms of its features, meaning its fields and methods. So let me go ahead and save this. And this is jfmain.java. As a matter of fact, I always do capitals, so jfmain.java. And I'll just rename it here inside of the text file itself. JF main. So just to make sure I have my names right, let me compile it. All right. So what I want to do really quick is hop out onto the website, onto the java.sun.com website, and just kind of show you where I'm getting this stuff from. Let me go start, run, and I think from the last time I should have java.sun.com in there, so let me click OK. And let's see, what do? We go over to the references and go into documentation. Java 2 Standard Edition Platform. Then I scroll down and I go to the Java 2 Standard Edition API, Application Programming Interface Documentation. And what I want to look up here in the packages here, okay, let me smush this over so you could see these are Java 2 Platform Standard Edition 142, all classes packages. I want javax.swing, javax.swing. So just kind of have to sing that old alphabet song and it'll eventually show up here. Here we go. javax.swing. And in here you'll find all of the swing classes. Now, what's interesting about the swing classes is most of the GUI components start with the letter J. So if I scroll down in here, you'll see things like JFrame, JLabel, whatnot. So let me go ahead and kind of scroll down in here. Here we go. And we can see things like, here we go, JApplet, JButton, JCheckbox, JCheckbox menu item, JColor chooser, JCombo box, JComponent, JDesktop pane, JDialog, JEditor pane, all these JLabel, JList, JMenu, JMenu bar, JPanel, JPopup menu, JProgress bar. I mean, look at all, JScroll bar, JScroll pane, slider spinner, everything. And this stuff, I love GUI programming in Java. Now, the main top level container that you put other controls in or other components is the JFrame. Let me slide this over here just temporarily. Look at its family tree. Look at its ancestry. A javax.swing JFrame class inherits from awt.frame, inherits from awt.window, inherits from awt.container, awt.component, and then finally up to java.lang.object. And as I've told you many times before, everything ultimately finds its way back to java.lang.object. It's kind of like Atom, okay? The root object, the root class is java.lang.object. So one would imagine, because of this rich family history here, you have a ton of functionality, and in fact you do. Now let's take a look at the class definition itself. It's public class JFrame extends, that means inheritance, frame. And it implements several classes here. Now, what is the implements keyword? Well, we haven't talked a lot about interfaces just yet, and that'll be coming up shortly. Right now, all you need to know is implements means it uses interfaces, which give you more functionality. So let's scroll down in here and see what we have in terms of some functionality. Look at the fields here. We have exit on close, root pane, checking enabled, okay? Now, look at the fields we inherit. We inherit these fields from java.awt.frame, like move cursor, southwest resize cursor, so we can change cursors. Here's things we have about the component. We can change alignment of things in terms of how we go ahead and lay things out. We have window constants like do nothing on close, dispose on close, several other fields. Methods are just as important too. Here are some of the constructors that we can use to go ahead and instantiate an instance of a JFrame. We can just have an empty constructor. We can pass a configuration, a graphics configuration object into it. We can pass a string or both. And here are some methods like add IMPL. By default, children may not be added directly to this component. They must be added to its content pane instead. So this method, a void method, allows us to pass a component, an object, and a position in terms of its index. Now, an important one that we'll be using is get content pane. This returns the content pane. That's what this means here. It returns the content pane in the form of a container object, and this is where we will call the add method to go ahead and add to the frame. Here we can specify J menu bars. We can get that. Okay, and usually for a get, there's also a set. So like there was get J menu bar, here eventually you'll see there's a set J menu bar. So get gives it to me, set allows me to set it or morph it. If I continue scrolling down, look at all of the methods that we inherit from the family that came before us. Here are all the methods that come from java.awt.frame, java.awt.window, java.awt.container, etc., etc. So this is where I'm getting this stuff from. And as I've said before, it's always critical that we go back to the API documentation because it is going to answer any and all of your questions about what a class can or cannot do in Java. So now that you've seen where the documentation comes from and what a JFrame can do, let's return back to our class. So we're creating a class called JFMain that in itself extends JFrame, which means it is a JFrame. So let me go to a constructor. Let's make a constructor. So JFMain. And in the constructor, I no longer, because I'm inheriting from JFrame, I don't have to say create a new JFrame and then call set title. Because I am a JFrame, I have a set title method. And I can go ahead and use it. And I'll say CBT nuggets application. Close the quote. I can also call the set size. So I'll say set size. And we'll make it, let's make it 200 by 200. Okay. And then I'll call the show method. Let me go ahead and compile it and then run it. Now when I run it, I get an exception. And if you recall, I said earlier that an exception is an error. And basically, I don't have a main method. I don't have one. So what I want to do is create a main method. Now I could go ahead and create a main method inside of this class. But I don't like doing that because what I like to do is have an application or a class that I use as the launcher. So let's call this public class app start. This starts our application. And it doesn't have, it's not going to extend anything. It's just the engine by which we start. So public static void main. And I put in the signature method that all Java applications must have in order to run, because that's what the virtual machine looks for. And I'm simply in there going to say new jf main.java. Okay, new jf main, not .java. That's the name of the file. So now if I go ahead and save this, and this is going to be called appstart.java. Let me move you back up here. Appstart.java, and I'll go ahead and compile it, and then I'll run the application, or I'll run this class, and because they're in the same directory, they can see each other. They have access to each other because they're in the same package by default. And a directory is really how a package is implemented, and I'll be able to go ahead and execute this application. And it looks like I had a typo, so instead of fjmain, I should say jfmain, because that's the name of the class. So jfmain, let me compile and run it again. So control 1 and then a control 2. And control 2, and we'll have our JFrame show up. Here it is. Now it looks like I've misjudged how large it's supposed to be because you see how application kind of got truncated. So I can move that over. I haven't specified that I want my JFrame locked down in any way, shape, or form. By the way, this icon is the default icon. And if I right click on it, I get the functionality here too. So I can close it. Now again, I don't have the functionality to actually quit the application. I just hide it, and the JVM is still running. So it doesn't quit until I go ahead and close the DOS virtual machine behind it. Now what I want to do is start talking about how we're going to lay other components out onto this JFrame, because I want to add a label, I want to add a button, all sorts of stuff. And let me go back to the java.awt class all the way up at the top here, or the java.awt package, I should say, all the way up at the top. And inside of there, we're going to find some what are called layout managers. And layout manager classes help us lay out or place onto our JFrame in an orderly way, so we don't have to, like pinpoint accuracy with an X and Y coordinates. We just kind of put it into default layouts. And we'll talk, there are several layouts, and they all end with layout. So there's a border layout. There's a card layout. There is a, keep on scrolling down here, a flow layout, okay? And these different layouts help me place components onto the JFrame, and they have different properties, and I'll go over the rest of them later. So there's a grid bag constraints layout, a grid bag layout, a grid layout, and the grid layout is one of the worst ones because this is where you literally have a grid and you pinpoint, I want this over at certain coordinates and whatnot. So we have the various layouts. Let me go back up to the border layout. The border layout is the default layout for a JFrame, and it's by far the easiest because what it does is it defines and divides the JFrame or a panel, which is what is really a lightweight container, into a couple of regions. And you can see the regions are north, south, west, and east. And they have constants that help us define those regions really nice and easy. And this is basically what it would look like. This is in an applet example, but we're doing a JFrame example. So we have north region is all the way up at the top, south is all the way at the bottom, center, west, and east. So what I'm going to do now is I'm going to return back to TextPad, and then we're going to lay out some additional components onto that form using the default layout manager, the border layout manager. Let me bring back TextPad, and let's go ahead and just start having some fun. So let me go back to my JF main, and I'm going to declare a label. I'm going to give myself, so I'm going to say JLabel, and a label is a read-only way of displaying text. In other words, a user cannot edit it. And I'll say LBL 1. That's a little confusing. How about LBL welcome? Okay, and that's a J label. And what I'll do is I'm going to come down here after I've set the size. It doesn't really matter. This is really kind of personal preference, but let me go ahead and move the set the size stuff down here. This just makes more sense to me. And I'm going to put a comment. I'll say JLabel stuff. And I'm going to say LBL welcome equals a new JLabel. and I'm going to say LBL welcome dot set text, not title, but text, and I'll say welcome to GUI programming in Java. Okay. Now, I have to add it to the JFrame. And I use the JFrame's get content pane to go ahead and give back to me the container that allows me to utilize it. So I simply say get content pane, and this returns to me that container. You know, I think I'm going to show you a couple of ways of doing this because there's a shortcut way and a long cut way. Here's the long cut way. I'll say container C equals get content pane. Okay, and get content pane returns the container to me. I say c dot add, and I'll put on LBL welcome, and I'll put it using the border layout, and I'll put it to the north. Okay, so let me go ahead and control 1 it and control 2 it. Looks like I forgot a semicolon somewhere, so let me go ahead and click. Oh, I inadvertently, I meant to do a control 1 and I just hit 1. So let me go ahead and make sure I'm holding down control and do a number 1, and then I'll do a number 2. All right, so I recompiled my JF main and I reran. I did a control C, control 2 on the app start, and here's what I get. So I'm going to have to probably make this a little wider, but you can see welcome to GUI programming in Java. I've successfully added a label to my JFrame. But you know what I really want to do is I want to create my own specialized label, one that displays the date. So let's go ahead and write our own JLabel. And as you probably would have guessed, we're going to use inheritance. Now, a while back ago, we talked about working with time and dates in Java. So I want to kind of utilize what we've learned and show you how to implement that inside of a Java Swing application. So I need access to my packages. So import java.awt.star, import java.util.star, import java.text.star, and import javax.swing.star. And I'm going to name my class, I'll say public class LBL or date label extends JLabel, and I will open that up and I'll save this as date label. So let me hit save, and this will be date label.java. And just to make sure I'm on the right track, I'm going to go ahead and do a control 1, making sure I'm holding down control and hitting 1 to compile that. Very good. Okay, so inside of the date label constructor, we're going to do some work. First thing I'm going to do is I'm going to go ahead and create a date object. So date today is a new date object. Date again coming from java.util. Then what I'm going to do is I'm going to create a date format, and I'm going to specify the locale. So I'm going to say date format df equals a date format, and then I call a special method to give me an instance of the date that I want in a specified format. So I'm going to say get date instance, okay, and I want it in a specific format. So let's say I want it in, let's do short. So I'll say date format dot short, comma, and the locale that I want will go ahead and be OUS. So I'll say locale dot US. Okay? So I've got my date format. And then what I do is I'm going to create a string to let me go ahead and store that in there. Or I can just go ahead and print it out. But I'm going to create a string. So I'm going to say string str date equals df dot format method format and today. Okay, let me compile that to make sure I'm on the right track with that. And it's a good thing I compile along the way here, because it's good to compile to see if you're on the right track, because you'd hate to have hundreds and hundreds of lines of code in there and have to go and debug it. It looks like I forgot a dot, so I'm going to recompile again. And this time, I am pretty good to go. So now watch this. Here is where the trick lies. Normally, we would do a system.out.println and print it out to the old standard output, but yuck, that's kind of boring for right now. So what I want to do is I am a JLabel. So I'm going to say set text to str date. Okay, let me compile that. Now, I can't really look at it just yet, but let me show you where I'm going with this. Now what I'm going to do is come back to my primary JF main method. And look at this. Remember the 5 tenets of object-oriented programming? User-defined data types, data hiding, encapsulation, polymorphism, and implementation inheritance. And I'm using a lot of them now. Now, you've seen me use implementation inheritance, but now I'm taking advantage of user-defined data types because I've got my own date label here. Check this out. I'm going to say date label, my DL, okay? Then I'm going to come down here, and instead of all this nonsense, I'm going to say my DL equals a new date, L-A-B-L-E-L, a new date label. Now that I've got a new date label, what I'm going to go ahead and do is I'm going to add my DL, MIDL, to the container. And that will have the date on there pre-configured. And the cool thing about programming this way is now I've got a date label. I create it once. I'll never really have to create that again. And I'm having good code modularization, and code reuse. That compiled, let's go over to App Start and do a Control-2. Voila! Look at that. There is our date. Right there. Pretty slick, huh? And when we talk about threads, I'm going to show you how to put a digital clock in there that actually tick, 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 ticks as it's going. So that's a pretty cool demo. Let's come back and add a couple more things. I want to put on a button. Let's go ahead and work on this button deal. So I'm going to come back to the date label. Now, you know what I've done is I've created a datelabel.java Java file, and in there I've got a class called datelabel. There's a couple of theories. You see, you can only have one public class per .java file, otherwise known as the compilation unit, but you can have several classes. Some people say you should have, one class per .java file. Other people say you can have many. So I already kind of called this already. So I'm going to close that, and I'm going to create a new file, and I'm going to allow myself to do more things with this one, as you'll see. So I'm going to say import java.awt.star import javax.swing, and I'm going to leave that as it is for right now. And I'm going to call this class. I'm not going to be public about it. I'm just going to call it class. I'm going to use just package level security. Class button, okay? Class button. And in this class button, I'm going to say button, or not class button, class exit button, if I could spell button, extends JButton. All right, now I am creating a J button. Let me go ahead and save that off. And what I'm going to do is I'm going to name it components.java. So components.java. Okay, save that up. It looks like I already had a previous file in there, so I'll go ahead and say yes to override it. Sure thing, go ahead and replace it, and voila. Now, because it's not public, you see only the public class has to be named the same as the compilation unit. So I'll save it. Let me go ahead and do it, Control-1 and compile it, and you'll see that it'll compile just fine. And here you go. Let me just hop out to the directory really quick and show you what's in there. So C/Java/swing. And let me bring that up, show you what's in there in terms of the files that I'm creating. Okay, here is the components.java. But I also created that button class. Let's go ahead and view by, something like details here. View details. And look at this. I've got my date label class, swing class, components, okay? But you'll notice that there isn't a components class yet, okay? No components.class file just yet. And as I start building this, if I put that in there, public class components, you'll see a public class, or a components.class file. But look at, this is what I really want you to focus on. Exit button.class. Exit button.class. Even though I named the compilation unit or this text file components.java, when I compile it, it creates this exit button class for me. Now, if I decide to put a public class in there, it must be named after the file name. Okay, enough said on that. So let's go ahead and work with this exit button for right now. So I'm going to say exit button, and I'm going to give myself a nice constructor. So exit button, and let's go ahead and set text to quit. Okay, let me compile that. Very cool. Now I'm going to come back to my JF main, and I'm going to create, using another user-defined data type, an exit button. What do I want to call this? Exit button. How about just my EB for exit button? And then I'm going to come down here, and let's go ahead and let me scroll down here to give myself some room to work. And let me just kind of move up so we could see what we're doing a little bit more. Didn't want to scroll down too much. Tab over. Exit button stuff. I'm a freak about commenting. Commenting is important. You really need to do it. Okay. My EB equals a new exit button. Then I'm going to do, now let me compare and contrast what I'm doing here. Here I did it kind of a long way, okay? Watch this. I've got a new one, so I can simply say get content pane. That returns to me a container, so now I'm virtually looking at a container there. So I could simply say add, and I could do my exit button and border layout dot south. I'm going to put it at the bottom. So let me compile this. Looks like I put an extra I in button, button, kind of like from, I don't know, Baton Rouge or something. So let me come over here and delete that little I and recompile. Again, I purposely, want you to see that I do make typos, I do make mistakes, and this is how you debug using a text editor like TextPad. Some of the tools like Eclipse might offer you a little bit more powerful debugging in terms of setting breakpoints, but for using a text editor, which most people use to program Java, this is how debugging goes. So you'll notice I always write a little bit at a time, then I compile. I write a little bit more, then I compile. That way I don't have to debug hundreds and hundreds of lines of code. Let me go ahead and run my app start, and here we have it. So I've laid out a JLabel up here, my own, and I've laid out my own button. Now again, the button doesn't work because we have not done event handling. In Introduction to Swing, I gave you a nice overview of working with some of the Java tools available for making graphical user interface programs. And I introduced you to the AWT and Swing packages, specifically java.awt and javax.swing, as well as the methodology of creating fairly basic GUI applications. But I did a lot more too. I showed you how you can use the tenets of Java or object-oriented programming, user-defined data types, data hiding, encapsulation, polymorphism, and implementation inheritance. Showed you how to use some of those as well to kind of give you a nice little review of what we've talked about. Specifically, I showed you how you can use inheritance. When you create a class that extends another class, you're inheriting. And we created several. We created a JFrame that extends from JFrame. We created our own button class that extended from JButton, as well as our own label that extended from JLabel. I hope you have found this informative, and I'd like to thank you for viewing.